Here, the objective for pneumatic circuit is to illustrate and study the continuous to and fro motion of a double-acting cylinder. A double-acting cylinder is used in forging and packaging industry where the continuous to and fro or up and down motion is required. The following pneumatic circuit with the help of double-acting cylinder should be able to first, provide continuous to and fro motion. Second, forward or extending stroke should act at a slow speed. Third, retraction stroke must be at faster rate than the expansion stroke. Apparatus that we will use in the circuit are FIL unit. FIL stands for filter, regulator and lubricator. Filter removes dirt and water, regulator adjusts and controls the air pressure, and lubricator reduces the internal friction of the equipment, and they are often used as a one unit. Next is a double-acting cylinder. In a double-acting cylinder, the working fluid acts alternatively on both the sides of the piston. What we have is a 5x2 pneumatically operated direction control valve. A 5x2 DCV has one pressure port, two vent ports and two exhaust ports. Then we have an adjustable flow control valve. A flow control valve regulates the pressure flow of the fluid. Then we have a 3x2 roller operated limiting switch DCV. A limit switch is used for controlling the machinery as a part of a control system with roller operated. And at last we have 3x2 push button. A push button is a simple switch mechanism which controls some aspect of a machine or a process. Now we talk about the circuit diagram. Firstly, we have a point where the compressed air is available. From that point, the compressed air is supplied to the FIL unit. After passing through the FIL unit, the compressed air is passed through the 3x2 push button. Then, as you can see here, there is a 5x2 DCV which is pneumatically operated. This pilot signal will be received by the roller switch. Coming back to the push button, the compressed air will come in contact with the 5x2 DCV, and this pressurized air will supply the input to the double-acting cylinder. Fluid will act on both the sides of the double-acting cylinder, that is in the head's end and the rod end as well. So to overcome the second requirement of speed of expansion stroke, we use a flow control valve in line with the check valve. Here we have roller switches, so when the spool rod will come in contact with these rollers, the DCV will activate, which will give the pilot signal to the main DCV. When the spool will complete the forward stroke, the other DCV will activate and it will give the signal to the main DCV. So by this way, the continuous to and fro motion of the piston rod will be available using these two pilot valves. This action of cylinder rod will continue till the push button is kept pressed. As soon as this button is released, the pressure line of compressed air will get disconnected. So as a result, the supply of compressed air will stop and the pneumatic circuit will stop working.
Okay, so now as we have seen in the circuit diagram, we will try to connect the physical circuits. So here the physical circuit is connected.